What has been constructed here is a bass boosting circuit. It's composed of a few different pieces. So to begin with, we have a mixer with a amplifier here. This potentiometer will allow us to have two different signals input, and as we wipe across, we can switch entirely from one to the other, which we'll be able to see in just a minute here. This portion of the circuit on the top right is a push-pull amplifier with a gain of 2. So whatever we input through this line here into the circuit will be boosted 2 times by the time it gets to the output over there. The speaker will be over here attached to the output over to ground, but this complex part down here at the bottom is a 6th order Butterworth filter. This is designed to cut off our frequencies above 300 hertz. Your bass frequencies are going to be anywhere between 50 to about 265 hertz. To make things a little easier, we push the limits, so we're clipping our circuit effectively between 200 to 300 hertz. So any frequencies beyond that will not be boosted by this circuit. They'll be clipped off. So for this part here, I just want to give a quick demonstration on how the mixer works with using the potentiometer here. Right now, on this function generator, I have a sine wave at 1 hertz, and off to the right, I have a function generator outputting a square wave at 5 hertz. So on the oscilloscope, I have one of the channels connected to the final output of the mixer, and one of them connected to the input from the sine wave to the right. So we see the two different waves because I've got the potentiometer turned all the way down to channel B right now. So we see both waves independently. But as I change the potentiometer and slowly fade between the two waveforms, we can see the sine waves start to slowly morph into a square wave, and if I push it all the way to be entirely channel A, my wave that I'm outputting from my mixer is now entirely channel A, which is why the waves now match. Again, if I wipe this back down all the way to channel B, I'll get my 1 hertz sine wave back out. The idea behind this is just that very quickly and easily I can switch between the filtered bass of the song that we play and the regular clean song without any filtering. So now I've hooked up the oscilloscope to the input and output of the 6th order Butterworth filter. We're going to see channel 1 in yellow, the original input wave. Channel 2 in blue is our output. We're going to adjust it using the function generator to the right here and watch what happens. So right away we can see our frequency currently is just about 1 hertz. Our input is 12.4 and our output is 52, which is about 4 times larger, which is the current design spec. The current voltage peak to peak are a little bit off because it's just a bad day for the machines. You can see there's a lot of noise in the waves that wasn't there when I did this earlier. But regardless, the filter will still function as intended. So as we increase the frequency, we'll go up to 5. We can see our wave get thinner and thinner. But our peak-to-peak voltage is still right around that 0.4 mark. Now this is going to stay consistent as we jump up faster and faster. So now we're at about 100 hertz. Waves are getting a little bit cleaner now. And that's going to stay pretty consistent. Our input and output wave is still right around that 0.4 mark. And that's going to stay there until I get just about 175, which is where I decided to put my corner frequency. So as soon as I hit that point, you'll see this blue wave start to decrease in amplitude. So at 200, starting to shrink a little more. And between 200 and 300, it's going to nosedive. Do that slowly. So we're at 300 hertz now. And we can see we're inputting 11 millivolts. We're getting out 20 millivolts. So much less than it was originally. If we go back, to our 0.4 times gain. We can also run a sweep. We'll do 5 seconds between 0 hertz and 500 hertz and see what that looks like on the oscilloscope. So again, it drops off pretty quickly, but the waves are about the same originally and then shrink very rapidly as we get past the 200 hertz mark. And bam, they're gone. So as great as it is to use the oscilloscope and the function generators to make sure the circuit is working properly, that's not why we made it. We made it to increase the bass of our favorite songs. So now we've got this big old speaker hooked up here, right to the output of the push-pull like we said we would. Just added a small capacitor to clean up the signal a little bit. And we've input our audio signal right here. So again, like we did earlier, right now I have it wiped all the way so we have the clean song. And after we start to play it, I can wipe it down and we'll go through our filter. We'll hear just the bass. Then I can wipe it anywhere in between. So I'll start the song and we'll play with it for a bit. A little harder to tell in the larger speakers, but it is vibrating quite a bit right there. So we can already hear, because our input signal is being multiplied by 10 and then again by 2, we're hearing a little bit of clipping. It's because the audio signal bounces back and forth between a high and low amplitude. It's hard to hear a good volume while also amplifying it through the speaker. But now we're going to listen to just the bass, so we're going to crank this down. So Freddie Mercury is still singing. We can't hear anything over 300 hertz. All we can hear now is the bass. If we can, put it somewhere in the middle. Go all the way back down to just the bass. Right back to the song. And altogether, that is how the bass boost works.